Hello everyone, hope you all are well. In this video, we will discuss certain numerical problems related to Gibbs free energy, equilibrium constant as well as with thermochemistry. Let's begin with the first numerical. Calculate standard Gibbs free energy for the conversion of oxygen to ozone. The reaction is 3 by 2 O2. O3 means 3 atoms of oxygen at 298 Kelvin and Kp is given this. Is there any relationship we have studied between delta G naught standard Gibbs free energy and equilibrium constant? Yes, there is the relation. Delta G naught is equals to minus 2.303 RT log Kt. Now on putting the values, you will get the value of this delta G naught. Minus 2.303 multiply. Here R is the gas constant. Here you see we have to calculate delta G in joule. So we take the value of R is 8.314 joule per Kelvin per mole because here the temperature is in Kelvin. So 8.314. Next, temperature is 298 Kelvin. Multiply log of Kp, which is 2.47 multiplied 10 raised power minus 29. On solving this complete expression, you will get the value minus 163,000 joule per mole. Now, if we want to convert this into kilojoule, we will divide it with 1000 and it will become delta G naught will become equals to 163 kilojoule per mole. Now come to next question. Find the equilibrium constant for the reaction. This reaction, ammonia is reacted with CO2 and it will form urea and water. For this reaction, standard Gibbs free energy is this at temperature 298 Kelvin. Now, again using this equation. Here, this is given and we have to calculate this. For this, log K is equals to delta G naught over 2.303 RT. Here the negative sign always there. On putting values, minus 13.6, it is in kilojoule and R we are using here is in joule. So we have to convert this kilojoule into joule. Now convert it into joule, or for converting to joule, multiply with 1000. Then it will become joule per mole. Next, 2.303 multiply, value of R is 8.314 multiply, temperature is 298 Kelvin. Now on solving, you will get 2.38. Now here the log K, we know the value, we have to find the value of K only, not log K. If we want to take log here, then we will write K is equals to antilog 2.38. Now you will see, to solve this, it is considered 10 raised power 2 and you will check the antilog of 0.38 in the antilog table and you will get the answer 2.4. This will be your answer. To solve any antilog, the whatever is written in front of the decimal, that will keep on 10 raised to power. And you have to check from the table after decimal antilog. That is from the table. Then in this way, you can solve such numericals. To solve this question, what we have to do? First, understand the question. Calculate the enthalpy change for the transformation of whatever you will understand, write down. Carbon graphite changes to carbon diamond. Its enthalpy change we have to calculate. Transformation we have to calculate. Got it? Given the enthalpy of combustion of graphite and diamond are. What is combustion? Combustion is basically the burning in the presence of air, means oxygen. Graphite in the presence of oxygen, and combustion of carbon diamond in the presence of oxygen. Now what you will get? You will get CO2 in gaseous form, CO2 in gaseous form. This you will get. Now what is the value of this graphite combustion? This is delta H combustion is equals to minus 393.5 kilojoule per mole. Units must be put. H combustion is minus 395.4 kilojoule per mole. This is the given things. Now, if we want this equation from these two equations, we want diamond, carbon, graphite this side and carbon, diamond in this side. You will reverse this reaction. Make it first equation, make it second equation. Reverse equation 2. Now what will we get? CO2 gas plus will be converted to carbon, diamond plus oxygen. Now if we reverse the reaction, this will also get reversed. Plus 395.4 kilojoule per mole. So now if we compare these two reactions, first and third reaction. Now write down the third reaction. Carbon, graphite plus O2, it will form CO2 gas, and delta H for this is minus 393.5 kilojoule per mole. Now on subtracting these two, what you will get? CO2 will cancel with it, oxygen will cancel with it. What you get? Carbon, graphite, it will changes into carbon, diamond, and what you will get by subtracting this will become plus 1.9 kilojoule per mole. This is the one way to solve this numerical. Just understand and reverse or multiply the reaction with the required condition. This is the numerical based on Hess law. We can solve it by the previous manner also, but in this case we solve it. First, calculate the enthalpy of formation of methane. What is the formula of methane? Write down the formula. For methane, what you have to add? Carbon plus H2, it will form methane. But we have to calculate delta H formation. This is our required condition. Now what is given? In combustion of graphite, carbon, graphite plus oxygen, it will form CO2 plus water with the combustion is minus 393.4 kilojoule per mole. This is delta H combustion. Next, combustion of methane, CH4 plus O2, it will form CO2 plus water. So delta H combustion is minus 890.2 kilojoule per mole. Third reaction, combustion of hydrogen, H2 plus O2, it will form H2O only. The enthalpy for combustion is minus 285.7 kilojoule per mole. Now mark these equations, equation 1, equation 2 and this is equation 3. Now this is our desired equation. This is carbon graphite. If I put graphite from here then there is no issue. This is carbon. We need carbon on this side. So we take this reaction as such. So we need only carbon from here, which is single and singly we need. Next, we need CH4 on this side. So we have to reverse this reaction. So what we conclude, 1, this second reaction will be subtracted. Now next, we need H2, but we need H2 twice H2. So multiply this reaction with 2 and we need this as such. So plus equation 3. Got it? Now write it in such a way, similar manner for this. First equation. It will become CO2 plus, instead of writing, now write according to this, C plus O2, it will form CO2. Third equation, 2H2 plus O2, it will form H2O. Correct. Now reverse this equation because we want CH4 on product side. So on reversing, CO2 plus 2H2O, it will form CH4 plus 2O2. Now what we will get? Here this is carbon, single. Here is O2, here is O2 and here is 2O2. This will get cancelled. Now H2. Is there any H2? No. Plus 2H2. Now, next. CO2. CO2 will get cancelled. This H2O. H2 will get cancelled. And here we get CH4. Now, see, this will be our desired equation. Yes. Now, this is equations get solved. Now, similarly, we can calculate enthalpy. First and third will be added. Delta HC 1 plus delta HC 3 minus delta HC second. Now put the values, minus 393.4 plus minus 285.7 minus 890.2 minus 393.4 plus minus 285.7 minus plus 890.2. Now first add these two. 7 minus 679.0 plus 890.2. This will be your answer. This will be the enthalpy of formation for methane. In this way, you can solve many much more numericals from your book. Now, to calculate the bond enthalpy of HCl, we can use the similar method as used by the Hess law, which is, what is our desired equation? Bond enthalpy of HCl means H2 plus half Cl2, it will form HCl. This is our desired equation. Enthalpy of reaction summation of bond energy of reactants minus bond energy of products. Now, what is the reaction? Half H2 plus half Cl2, it will form HCl. Now, if we apply this formula, what we have to get? This is already given, which is minus 91, which is equals to bond energy of reactant 1 by 2. What is the bond enthalpy of H? This is HH. This is 430 minus plus. This is reactant. Another reactant is Cl2. This is half Cl. Value is 242 minus, now enthalpy of product, minus 1 multiply. This we have to calculate. Bond energy of product. We have to calculate. Now on solving, 2 ones are 2, 2 twos are 4, 2 ones are 2, 2 fives are 10, 2 ones are 2, 2 ones are 2, 2 twos are 4, 2 ones are 2. You will get 215 plus 121 minus bond energy of HCl. Now 91 is equals to, on adding this, 5 plus 1 6, 2 plus 1 3, 2 plus 1 3 minus bond energy of HCl. If we move this here and this here, what you will get? Bond energy of HCl will be equals to 336 plus 91, which is 427 kilojoule per mole. This will be your final answer. So in this way you can calculate the bond enthalpy. Remember one thing, if we talk about CH4, here we consider the enthalpies of every CH bond is different. So in every case, here the enthalpy of CH bond enthalpy is different. If we talk about in ethane, here the bond enthalpy of CH is different. So it is according to the question you have to apply. So this is all about the numericals related to thermochemistry. That's all for today. Thank you and have a nice day. Next we will begin with the new chapter. Kindly like, share and subscribe this channel.